Welcome to True Projects. In this video, we are going to explain about the project that is Bridging Precision and Complexity, a novel machine learning approach for ambiguity detection in software requirements. So before getting into the execution, first let us understand what is this project about. Software requirements. They are the foundation for any software project. When these requirements are vague or unclear, different people may interpret them in different ways. This often leads to misunderstanding, errors during implementation, and delays in the project timelines. Fixing these mistakes can increase development costs and also create frustration among team members and stakeholders. The problem becomes even more serious as software systems grow larger and more complex. In such systems, unclear requirements can cause miscommunication between developers, testers, and clients, which may ultimately affect overall quality of the final product. Ensuring that requirements are precise and well understood is therefore essential for building software that meets expectations effectively. And in the past, software teams often relied on manual methods like carefully reviewing requirements or holding walkthrough meetings to spot problems. While these methods can work well for small projects, they require a lot of time and effort, and the results can vary depending on who is doing the review. For large projects with many requirements, these traditional approaches become impractical. And to solve this, automated methods have been developed. Rule based systems look for specific words or patterns in requirements, making them easy to understand. But they can miss more subtle issues. On the other hand, machine learning models can identify complex patterns and context, catching ambiguities that rules might overlook. However, these models can be harder to interpret and may not scale easily for very large projects. So, neither manual or automated methods by themselves are enough to handle all the different types of ambiguity that appear in real world software requirements. Some ambiguities are subtle or content dependent, making them hard to detect with a single approach. So, because of this, ambiguity in requirements remains a major challenge in software engineering. To avoid misunderstandings, mistakes, and project delays, it is important to develop better solutions that can clearly identify and manage ambiguous requirements, helping teams build software more effectively and accurately. So to overcome with all such issues, this project it aims to detect unclear or ambiguous statements in software requirements by combining the strengths of two approaches. So here we are proposing a hybrid approach which combines two approaches. One is rule-based techniques and the other one is machine learning. So first it starts with rule-based method. So it works like a checklist of commonly ambiguous words and phrases, such as may, approximately, or typically. This helps the system quickly identify statements that are likely to be unclear, and the approach is easy for users to understand and interpret. While rule-based method can catch common ambiguous phrases, they may miss more subtle or complex form of unclear language. To address that, this project uses machine learning techniques which can recognize patterns and context that simple rules cannot detect. And here, the text of requirements, that is the text of the requirements, is first converted into numerical form using TF-ID of factorization, which measures how important each word is within the document. Then a random forest classifier is used to automatically classify statements as ambiguous or clear, and this combination allows the system to detect ambiguity more accurately and cover wider range of unclear statements that rule-based methods alone done. And in addition, this project it incorporates clustering analysis. So in addition to detect ambiguous statements, the system uses cluster analysis to group requirements that share similar language patterns. This helps to identify common types of ambiguity and shows how unclear statements appear across different domains such as healthcare, finance, or e-commerce. By organizing requirements in this way, teams can better understand patterns of ambiguity and focus on the areas that need the most attention. And the system also uses sentiment analysis to examine the emotional tone of the requirements. This allows it to explore whether certain emotions or writing styles are linked to ambiguity. By combining these analyses, the system provides a deeper understanding of not just which requirements are unclear, but also why they might be unclear for a stakeholder perspective. And to further improve the performance of this project, several additional techniques are added to make the system more accurate, transparent, and user friendly. So, to handle data balance, Here we are incorporating smooth technique. It is used to balance the dataset, ensuring that all categories are fairly represented. And the system also uses bag of words along with the DF IDF to convert text into a format that machine learning models can understand, improving the equality of the feature representation. And here, advanced models that are XGBoost and the ensemble model that is voting classifier are also incorporated to boost the prediction accuracy and make the system more robust. After that, to make the results more interpretable, explainable AI techniques that are LIME and SHAP are integrated, allowing users to see which features contributed most to the predictions. SHAP is integrated, allowing users to see which features contributed most to the predictions. And here we have developed Flask-based web application, which uses Flask framework to develop web application where users can give the input and get predictions interactively without dealing with the code, that is dealing with the complete backend. And then comes topic modeling. So here we have used latent dirichlet analysis, that is latent dirichlet allocation for topic modeling, and it is applied to uncover hidden themes and patterns within ambiguous requirements, giving a deeper understanding of the data and helping stakeholders to identify common sources of ambiguity. Moving on to the implementation. To implement this project, we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented the project. First step is importing the libraries. So first we will be importing all the necessary Python libraries for data processing, machine learning, visualization, and deployment. So these provide the tools needed for performing each step of the project. Then coming to data ingestion part. So at this stage, the data set for ambiguity detection in software requirements is sourced from the Kaggle. It is loaded into Pandas data frame, which makes it easy to manipulate and analyze the data. Then comes pre-processing. So at this stage, first basic cleaning, that is the text is normalized by converting to lowercase, removing HTML tags, URLs and non-printable characters and handling punctuation. Then comes advanced cleaning, where text is tokenized, that is split into words and stop words that are common words that add little meaning are removed. Then comes feature engineering and labeling. Here, ambiguities are labeled using rule-based methods. Sentiment of the text is labeled using text block. And K-means clustering groups similar the requirements, with optimal clusters choosing that are chosen using the elbow method. Then label encoding converts categorical labels into numerical values for modeling. Then comes embedding and vectorization. So at this stage, text is converted into numerical form using TF-IDF vectorization technique, which captures the importance of the words for the ambiguity detection and sentiment analysis. Then comes data visualization. So the distribution of the sentiment categories is plotted to understand trends, and word clouds are generated to visualize the most frequent words and patterns in the text. Then comes data balancing. So here we applied smooth to balance the data set, ensuring all classes have sufficient representation and improving the model performance. Then comes feature extraction and data splitting. So here features are extracted from the pre-processed text and the data set is split into training and testing sets to train the model and evaluate their performance. Then comes model training. So here baseline models that are machine learning models such as random forest, SVM, KNN, MLP, logistic regression, decision tree, and naive Bayes are trained, and extension models with these mode balanced data set that are bag of words, TF-IDF based ensemble models combining with multiple algorithms and Bow based ensemble models are further improve the project. That is, they are further developed in this project. And to evaluate all those models, we have used accuracy, precision, recall, and FN score. And coming to this confusion matrix is used to analyze to see false positives and negatives. And here we have used LIME and SHAP. It is used to understand which features influence the predictions. And the best performing model will be saved for the future use. Coming to the part of front end. So here a Flash-based web application is built with an input form or a file upload option. So the pre-trained model and pre-processing pipeline is loaded. User input is pre-processed, vectorized, and passed through the model to predict ambiguity. And topic modeling, it identifies top words or the themes in the input. And the results, including class labels, confidence scores, and insights, are displayed interactively on the web interface. So this is how we have implemented the project. Now coming to the algorithms used. So these are the basic machine learning models used, and these are the extension models used. And these are the clustering and labeling methods that we have used in this project. And to implement this project, we need software and hardware requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are Application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are needed. And this is the overview of the project. Let's execute it. To execute, let's open the code folder of the project, which contains source code files. So let's open it. These are the source code files which are important for this project's implementation. And here in this folder, we have the dataset that is used. So let's open it. And here we have dataset in these two folders. So this have an FR dataset. Here we have multiple requirements. So this dataset is used to train the models. We have multiple requirement files. So close this. Get back. And this is the model folder in which we have algorithm information, and this will be loaded into the project code during runtime of the application. And this is the static folder. This folder contains files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder in which we have HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases. So here we will be having sample files that we will be using in the front end. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Here we have notebook files. This is a Jupyter notebook file which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. And here we have topic modeling file, which is a Python code file. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. Copy it. Now open Anaconda prompt. So you can see Anaconda prompt is open. Now give the command cd, give the space, paste the copied path, and click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So just wait for a while. File is being compiled. So at this address, application has been hosted. So copy this local link provided by the Flask framework and paste it in any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here and now click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So now you can click on register, or you can click on get started. Let's click on get started and create an account. I have already created account, so I'll directly log in. For creating account, you need to fill in all these details. So let's sign in. Click on sign in. Give your username and the password. Click on login. Click on sign in here. And we have signed in successfully and redirected to prediction page. So here you can see a text box, right? In this text box, we are supposed to provide the input to get the prediction. So here, if you click on view analysis, you will be redirected to this graphs. So first, let's do the prediction. So let's give here open test cases, open samples. So let's apply filter to it. Click on OK. So let's check with this one. Now click on Analyze Requirements. So this given information, it will be pre-processed at the backend. It will be fed to the train model, and then train model will be giving us the output. So just wait for a while. And here we have the output. that is we have the prediction. So here we have model confidence, which is 99.27%, which is very high. And here you can see the prediction to be as ambiguous text it is. The given text is of ambiguous text, and topic analysis, it is of topic 1. The text has been classified into topic 1 category based on semantic analysis. And here we have key terms of the given text. And here we have analysis summary where we have 30 words, 174 letters, and 2 sentences in which we have given. And here we have the analyze new text and view models graph. Let's analyze new text. So click on that and apply it. So here you can see accuracy rate of this project, and you can see requirements analyzed, time reduction, algorithms used. So we have totally used 14 algorithms, and here we have 2500 requirements that we have analyzed, and here we have of 99.6% accuracy rate. So let's copy the other text, copy it, get back, paste it, click on analyze requirements. And here we got the prediction that is 90.12% accuracy. And here we have prediction to be ambiguous. And here we have topic analysis of topic 1, key terms, and the analysis summary. Let's analyze new one. So let's apply filter to non-ambiguous. Click on OK. So select any text of your choice and then come back and paste it. Click on analyze requirements. So here you can see we got 99.94% of accuracy, and here we have prediction that is to be not ambiguous. So based on the given requirements, it is predicting that it is not ambiguous. And here we have the key requirements, analysis, summary. Let's try with the other text. So copy any other text, get back, paste it, and click on analyze requirements. So here we got the prediction that it is not ambiguous. And here we have topic analysis with the 99.89% probability score. So here we have topic analysis, here we have key terms, and here we have analysis summary. Click on analyze new text. Let's try loading the random sample data. So click on load sample. So here if you see, we have loaded a sample generated text. Now click on analyze requirements. So here if you observe, we got the prediction to be ambiguous. And these are the key terms of the given sentence. And here is the analysis summary. So now let's view graphs. So click on view model graph. And here we have sample outcome graph. So here on x-axis, we have the classes that we are predicting, and on y-axis, we have count of each class. And this is the confusion matrix. So here on x-axis, we have predicted label, and on y-axis, we have true label. Close it. And here we have accuracy score. So here on x-axis, we have all the models that we have trained, and on y-axis, we have accuracy. Close it. Accordingly, we have precision score, recall score, F1 score, and here we have sharp explainable AI feature importance graph. Close it. Now click on log out. So in this way, by automatically detecting unclear or ambiguous requirements, this system helps teams communicate better, reduce mistakes, and also save the time and resources. It makes software projects smoother and ensure that the final product matches what stakeholders expect. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.